Look at this amazing effect. So this is our new thermal imaging device. Unpacking test. We're entering the 2.0 era of thermal imaging. The packaging is still the same packaging. The box is still the same box. Open the box and remove the small box inside. What comes into view is a manual. This is the thermal imaging manual. Open the small box. This one is installed under the microscope. Thermal imaging bracket. Design with Vientiane arm torque. Real-time transmission of images using the Type-C data interface. Compared to the design of the female head of the previous generation, the Type-C data cable of this unit, any mobile phone data cable can be replaced. This small bag, it's the main frame of our thermal camera. The lens has an aperture of f6.9. 12A continues to use the ratio of the previous generation of large mirrors. The difference is, a 3.5 macro mirror is also superimposed inside. That is to say, you can watch the full page at the same time. You can still zoom in infinitely. So that we are very simple to overhaul 1-10 mA of current, although this design requires very high precision. But it solves two pain points. 1. Can easily check 1-10 mA clearly visible. 2. No matter how big your image is. How big are the details? Still very clear. And no distortion will occur. It means that the image will not be deformed in any way. Okay, let's mount the thermal camera. Installation is very simple. That's it, one card and one bend are done. Then plug in the data cable. Just open the computer software. Now we're going to create a plate. Direct viewing of clarity at room temperature. Thermal imaging becomes very clear when it is cold or hot, but clarity at room temperature. This is very rare. That is, this thermal imaging uses a new IM architecture, as written. It is also very clear in the case of cold plates. The thermal imaging of this 2.0 is different from the previous generation. In theory, it can be upgraded indefinitely. It is a brand new IM, after 8 months. Overturn the previous brand new algorithm. Okay, let's power up. Take a look at the leakage status. Output, this is a short circuit board. Okay, see it? The chip is clearly visible. And look again at infrared light. Different variations in the 4 pseudo-color mode. Which model do you prefer? Everyone's habits are different. Welcome to discuss in the comment area. The bottom plate has only 3.8 milliamperes leakage. Whether the thermal imaging is K X depends on this current. See if it's clearly visible. The capacitor above. Change a few more modes. Take another look. Look at that capacitor leakage. Only 3.8 milliamp hours. If you feel that you are not seeing clearly enough, okay, lower the microscope. Then make the picture quality bigger. Is it very easy to see clearly at this time? This 3 milliamp hours capacitor is leaking. And of course you can go even bigger, 3.8 milliamp hours. Almost no temperature. At this time the main board is heated up. That is, what happens in the case of a big short circuit. How clear is it? We'll see. This magnification is twice as large as the previous magnification. Take a look now. There is also a progress bar at the bottom. You can stretch it 4 times. Are you satisfied with this clarity? Thermal imaging with a resolution of 256 × 192. Of course, the frame insertion process is used, so this intermediate development process. The sadness you never know.